Hi, I'm Victor.
I'm George.
I'm Jesse.
Gary.
And this is our suspension system for the Grand Suspension Challenge for ME 2030. Hello, this video is for the Grand Suspension Challenge from the Cal State LA ME 2030 design class with Professor Landsberger. The goal of this video is to showcase the design that we worked on and the scooter that we made. So the goal of this challenge was to be able to create suspension for a scooter or for a skateboard. We chose a scooter, and we chose to use a spring to be able to create our suspension. The goal of it was to go over a 3 3/4 inch bump and to reduce the hit from when that you would experience when going over a bump, as opposed to having a scooter without any. All right, guys. So my lovely assistant here is gonna show us about what I'm talking about as I go through the suspension components. The way that our suspension works is by using a 2-inch compression spring to absorb bumps, and the spring sits between 2 disc plates that we machined out of solid aluminum to hold the spring nice and tight. The shaft that went inside the handlebars was extended by putting a solid rod, steel rod inside the shaft, and then we connected it to another piece of shaft that we cut from another scooter. This allows the shaft to be connected to the handlebars and the fork. That of course allows us to also steer, and all the suspension components go to operate independently of the shaft to make sure that we can reduce friction. There is also a machined PVC sleeve, which you can see here, and in between the neck that is attached to the front platform of the scooter, it also goes in between the spring and the shaft that attaches to the fork. It allows free movement of the handlebar shaft that connects to the fork, and it just allows us to be able to not have a lot of friction there when you're trying to steer and maneuver. So next we're going to talk a little bit about each part that goes into our design. Once again, we have an assistant here that he's going to help us take a quick look. First thing that we worked on was finding a spring that would work for us. This is a 2-inch length long spring with a 1.7-inch outer diameter and a 1.3-inch inner diameter. It has a 165 pound per inch spring rate. We went through this actually are the fourth spring that we bought. The first one was too strong. It was a little bit too stiff, and we bought some other ones that were the same size, but they were still a little too stiff. This is the one that we settled on. It worked the best. Now we're going to talk about the disc plates, and these are the disc plates that we machined. They're very similar to each other, but one of them has an indent for the bottom part of the fork. Yeah, so that it's able to move freely. It matches, so the indents on it actually match the bottom part of the fork, so that it doesn't have extra friction. And then the other part of it, as you can see, that allows the spring to sit in there nice and snug, and that way we don't have we have just a very small amount of movement that gives it just enough of movement for it to absorb vibrations, but not so much that it feels unsafe or unsteady. The other one is just is a little bit simpler version of it. This one allows us to mount on top of the spring, and also to have the bearings from the shaft, which we see here, to go on top of it, and then these go underneath. This goes all the way on top into the bottom part of the neck of the scooter. Now we can talk about the PVC sleeve, which we have here, and this is a PVC pipe that we took and used a lathe to machine off material until we found we had the right diameter, inner and outer diameter, to fit over our solid shaft. As you can see here. Yes, it's very dirty, but obviously we have grease inside it, and on the outside that's helped us reduce friction. This also goes in between the sleeves and the spring, and allows there to be minimal friction. So now we're going to talk about the shaft that connects to the rod. Sorry, to the fork. So this is the original part, where you see him. His finger right there in the middle is showing the other part that we had to use from another scooter. We had to machine this as well to make sure that the threads would end up matching close enough for us to have a nut over it to be able to tighten and mount the handlebars. Just like that. Now this is obvious. The next is going to go in between that, but it's just demonstrating how the nut can go over both parts of the thread. So what we have here, we actually have a solid steel shaft in between that allowed us to connect both threaded rods that we have here. Inside, it's actually cemented so it's very secure, and it allows us to be able to have that extra distance between the fork bottom and the top of the neck, and that allows us to be able to have suspension travel. So those are the main parts that we actually worked on. We did try out. There were other things that we tried first, but this is what we settled on because this is to us the simplest and most convenient, and also approach that isn't too hard to recreate, and also works well. It makes the scooter feel like it felt before. It just has suspension now. It actually, you can feel it has a little bit of give. So when you hit bumps, it's not as jarring. All right, here we have Jesse putting together the scooter again. So he put on the spring, and now he's put on the second disc plate. Now he's gonna go ahead and put the sleeve in. There we go. Now he's popping the bearings back on the top part of on the bottom part of the neck, and then the top. Here we go. Now it's on the top part of the neck, and now we're having the knot that allows us to secure the handlebars to it. See, now we have a bearing in between here so that there's no damage and there's nothing hitting. There's no damage to the neck or to the nut that we have fastening the handlebars. Oh, he's almost done here. All right, almost there, Jesse. You got this. Okay, now we can throw on the handlebars. Okay. And we just use an Allen key to tighten up the clamp. The clamp here. So it's pretty easy to assemble. It literally took him 2 minutes to assemble this, and it's already ready. Now, if you can please demonstrate putting weight on it so you can show the compression.